Yes, everybody, very good evening all. I hope that everybody can see me. Yes, am I visible, I guess? Yes or no, everyone? Come on, guys. Yeah, so happy to meet you all back in this session. Okay, nice, everybody. So let's begin the session today. So today we are going to make a very quick revision. So that is going to be on our enzymes. Okay, so enzymes and inhibition are seriously very important topic for our preparation. Okay, so let's see in detail about this enzymes. Okay, right. So exactly what are going to be these enzymes? Literally these enzymes, they are very important molecules, right? So the enzymes, they are nothing but they are going to be the catalyst. So what will be a catalyst doing? I am a catalyst. So what I am doing? I am inducing you to prepare better, right? So that is how the enzymes will be doing. The enzymes, they help to make a better performance of the reaction. Okay, right. So these enzymes, they are going to speed up. Okay, so what they are going to speed up? They are going to speed up the rate of the reactions. Okay, so before beginning on with our inhibition, we will have a quick look into the definitions of the enzyme. The first definition of the day, it is going to be on the holoenzyme. Right. So what do you mean by holo? Holo means whole. Whole means it is going to be the complete unit. So the complete enzyme is what is called as the holoenzyme. Right. Next keyword, it is called as cofactor. Right. So what is going to be the cofactor? So what does this cofactor indicate? Cofactor tells us about the additional chemical component alone. So it is basically an inorganic element. Okay. Yes, it is going to include only the inorganic element. It is not at all going to include any of the other things. Yes, it is going to include only the inorganic elements. So what are the inorganic elements? Like Fe2 plus, Mg2 plus, Mn2 plus, zinc. So all these are inorganic components. Okay, so the presence of these inorganic components, they are only going to represented as a cofactor. So where will this cofactor bind? This cofactor is going to bind to a part of an enzyme that is called as an apoenzyme. So what is the part called as? It is called as the apoenzyme. So this small fellow, if he is going to be inorganic, right? So this will be called as, this inorganic will be called as a cofactor. Okay, right. So this big region is what is called as the apoenzyme. Together, this apoenzyme along with this fellow cofactor, together they make up the holoenzyme. Yes. So all these three things are thorough to you. What is an apoenzyme? What is going to be the holoenzyme? And what is going to be the cofactor? Right. So cofactor is going to be the small component. It is an inorganic in nature. So that is called as cofactor. Apoenzyme is the protein part. Together this apo and cofactor is going to make up the holoenzyme. Right. The next one, it is going to be what is the coenzyme. Right. So what do you mean by the coenzyme? Coenzyme is nothing but, yes, the apoenzyme is going to remain the same. This is going to be your apoenzyme. But what is the coenzyme? This component, it is going to be the organic. Okay. So if it is going to be an organic component, then you call them as the, coenzyme. Okay, so cofactor means it is inorganic. Coenzyme means it is going to be the organic component. Okay, the next one, it is going to be the prosthetic group. So what is a prosthetic group? This prosthetic group, it can be either your coenzyme or it may be your cofactor. Both can behave like a prosthetic group. But what is the definition? This prosthetic group, it must be covalently bound to the enzyme. So what it should do, this prosthetic group, it should be covalently bound. Okay, so unless and until it is going to be covalently bound, then only it is called as prosthetic group. So let it be your coenzyme or let it be your cofactor, no issues, right? But it must be very tightly bound. Okay, so only if it is going to be very tightly bound, yes, that is what is called as your prosthetic group. Yes, so this is till now it is all clear to you what is a horoenzyme, what is a cofactor, what is going to be a prosthetic group. Yes, okay, right everyone. So we will see in detail about the next important definitions. Yes, okay. So few terms are always very much welcomed in our subject. So this is called as the active site. Yes, right. So what is going to be the active site? Okay, the active site, it is going to be the catalytic site. So it is the exact region where your substrate is going to bind. Correct? So the exact region where the substrate is going to bind, it is what is called as the active site. So it is the site where the substrate is going to bind. Okay, so that is what is called as the active site. And what is the substrate? The substrate, it is going to be the molecule that is going to be bound to the active site and it is going to be acted upon also. That is what is called as the substrate. So what is the Km? Yes, so Km, it is going to be the substrate concentration at half Vmax. Many a times this also comes in your examination. So what is the Km? Okay, so at your 1 Vmax. What should be the Km at 1 Vmax? Half Vmax, it is going to be 1 Km. So 1 Vmax, it should be 2 Km. Got it? Yes, this is how you have to find out the answer. So 1 Km, it is equal to half Vmax. So if it is going to be 2 Km, what should be the Vmax? It should be, so what should be your Km? It should be 2 Km. Okay, right. So this Km is nothing but it is going to be the substrate concentration that is present at half Vmax. Right. V0 is the initial velocity and Vmax is going to be the maximal velocity. And you remember the Michael-Mendelen's constant V0. V0 is equal to Vmax into S divided by S plus Km. Okay, right. So if you substitute this, you will be getting the derivation also. Yes. So shall we just try it out? For example, you want to substitute something. I'll just show you an example. Let us take this 2 Km. Okay, right. So I'm going to take it as a 2 Km. Shall we try it out? Everybody in the class, come on guys, let us try it out with your S is equal to 2 Km. Okay, so this is your MM equation. Here I'm going to take S as 2 Km. So now let us see what is happening to your V0. So V0 is equal to Vmax into 2 Km, right, divided by S plus 2 Km, sorry, Km plus 2 Km. Yes, so it is going to be Km plus 2 Km, right. So now Vmax into 2 into Km divided by 3 Km, right. Fine. So this Km and Km is going to get cancelled, right. So your V0, it is going to become your 2 by 3 Vmax. Got it? So if your Km is going to be doubled, so what is going to happen to your Vmax? Your Vmax will become 2 by 3. Yes? So that is how we have to understand this kind of equations. Alright, so I hope that this basics is all clear to you. Now we will make a move towards the next important aspects. Yes? Okay, fine everybody. So let's see the next important aspect. So we are going to make up a move towards the inhibitor. Okay, fine. Yes, all. Okay. So the next one we are going to see, it is about your equation. Okay, right. So equation is going to be your Michael-Mendel's constant. Okay, right. So this equation, it is what is telling us more information about our behavior of the enzymes. Right. So it tells about how is our enzymes it is doing up and on. Okay, so if you take what is the shape of your enzyme kinetics. So this is a graph between your S, that is the substrate, and V, the velocity. Okay, so when we plot your V versus S, okay, so remember S should be in your X axis, V should be in your Y axis. Okay, so this is what is your plot. Always whenever you are studying, please study with the units. Okay, so this is going to be S, usually it is millimolar. Okay, and this is going to be V, the velocity, it is micromolar or your millimolar per minute. Okay, that is going to be the velocity. And how it is going to be the graph, it is a hyperbola. Okay, so how it is going to be the graph is making to be a hyperbola. Okay, right. So there are two orders. You can see that here it is a 0 order and here it is going to be the first order. So this is how the equation is like behaving with. Okay, right. So this is going to be the V max. This is going to be the V and the S. So now you see this Km. So what is this Km? Km is the point exactly that is going to be half V max. So what is Km? Km is the point exactly, it is going to be the substrate concentration at which V is equal to half V max. Okay, right. And then you see that there are two orders. Number one, it is going to be the first order and the other one is 0 order. Let me take the 0 order. So 0 order, whenever it is reaching the 0 order, that means that your V0 is going to become like V max, correct? Your V0 is reaching V max. Under that condition, when your V0 is reaching the V max, it becomes independent of your substrate. Okay, so whatever is going to be the substrate concentration. So let us take this is 0, this is 10, 20, 30, 40, 50, 60. Even if it is 30 also, it is the same. Even the substrate is 60 also, it is the same. What does it indicate? Even though you increase the substrate concentration, nothing is going to take place regarding the V max. So, in case of 0 order kinetics, it does not depend upon S. So, what it is depending on? We know the equation. What is the equation? V0 is equal to V max into S by S plus Km. Right? Yes. To reach this point, so what is the velocity? It is the rate of catalysis of your enzyme plus substrate. Yes. How it is going to convert it into product. Right. This is going to be independent of your substrate, but it depends on the enzyme concentration. So it is going to depend on the enzyme concentration. Even though it is not dependent on the substrate, this is going to dependent on the enzyme concentration. Okay. So what about your first order kinetics? First order kinetics, it is going to be proportional to the substrate concentration. See, when you increase the substrate concentration, the V is also proportionately increasing till this stage, correct? This stage only it becomes the 0 order. Till that stage, as you keep on increasing your substrate, the V is increasing. So this is what is called as the first order reaction. Understood? So now everybody got what is going to be the first order reaction. Yes, and this is a very, very important formula. This is what is called as equation or formula. Many times, many exams, many questions have come from this. Yes, so definitely never ever forget to memorize this formula. What is the formula? V0, it is equal to V max into S divided by Km plus S. So Km will be equal to S. when your V is half V max. Okay, so your S and the Km, it is going to become equal. Okay, then what will happen? Let us check. Let us substitute Km as S. V naught is equal to V max into Km. Yes, divided by Km plus Km. Now what will happen? You have to check everything. No, V max into Km divided by 2 Km. So Km get cancelled. So now V is becoming V max by 2. That is what they have given it as half V max. So whenever your Km is equal to S, your V naught will become half V max. So shall we try one more? Shall we check what will happen to my V max if my S is equal to Km divided by 2? Shall we check? Everybody in the class, just check out with me. In this formula, V naught is equal to V max into S divided by Km plus S. So this is going to be your equation. Now you are going to substitute S as Km by 2. You are going to find out what happens to your V max. Shall we find out? Yes. So this will become V max into Km by 2 divided by Km plus Km by 2. So now what you will do? Yes, into Km by Km by 2. So this is going to be V max into Km by 2 divided by 2. You take it as a denominator. So this becomes 2 Km plus Km. Right. So this 2 and 2 will get cancelled. So that is equal to V max into Km divided by 3 Km. Right. So Km get cancelled. So V naught will become V max by 3. So when it will become V max by 3? Whenever you are making your S as Km by 2. Got the logic now? Everybody in the class, did you understand like how and what makes your equation to be changed? Yes. So shall we just make up a move? Okay. So under the normal condition, we saw that what is going to be the curve? The curve is going to be hyperbolic in nature. So what is going to be the curve? The curve is going to be hyperbolic in nature. But whenever it is undergoing your allosteric effect. So whenever it is undergoing the allosteric effect. Okay. So under the allosteric effect, what it will show? It will show the sigmoidal curve. So under allosteric effect, what kind it is doing? It is doing with the sigmoidal curve. So the sigmoidal curve of this allosteric, it is allowing or indicating the cooperativity theory. So what is the theory? It is the theory of cooperativity. Okay. So it is the theory of cooperativity. Okay. Right. So this is very, very important. So what it follows? It follows the theory of cooperativity. Okay. So this is all fine to you, clear to you, right? Fine. So what is your equation? V naught, it is equal to V max into S divided by S plus Km. Agreed or not? Yes, everybody in the class. So do you agree that this is going to be the thing? Yes? Okay, fine, fine everyone. That's great. Yes. So, right. Yes. So, shall we just see now what is happening? Yeah? Okay, great. So, now you are going to take an invert. Okay, so it is called as the invert plot. So, what it is called as? It is called as an invert plot. So, what we are doing with this invert plot? You are going to take the inverse relation. Okay. So, now your V naught is going to become 1 by V naught. Okay. Alright. And your V max will become 1 by V max. Correct. 1 by S into V max. Okay. So, this has become as such. Alright. Then, if I have to take S plus Km. So this is going to become inverted. As such, can I take them as inverted? Is it possible to take as such inverted? It is an inverted plot, correct? So this is going to be your S plus Km, right? So this cannot be taken as such. So what you are doing? You are going to take the inverse. Okay, so the inverse is going to become like S plus Km divided by V max into S. Okay, right. So now you are going to take this as a denominator and then you are going to work on something. Okay, so then you will be getting this, your 1 by V naught is equal to Km by V max plus S plus 1 by V max. How did you get it? Simple solvation, right? So it is going to be S divided by V max into S plus Km divided by V max into S, right? So S and S get cancelled. So this becomes 1 by V max plus Km by V max into S. Got it? This is what is called as the invert plot. This is what is called as the Lion-Weaver-Burg equation. So the first equation you have to remember is V naught is equal to V max into S by S plus Km. Yes, and the second equation is going to be the inverse plot. Right. So what is going to be the inverse plot? The inverse plot, it is going to be 1 by V naught. So 1 by V naught means it is going to be the reverse. So S plus Km is going to come on the top and V max into S is going to go to the bottom. So you are going to make it individual. So S by V max into S plus Km by V max into S, that makes your Lion-Weaver block plot as 1 by V naught Km divided by V max into S and 1 by V max. Why this is so essential? Because you are going to make up one more graph. This is what is called as Lion-Weaver-Burg plot. Yes. So what is the equation? 1 by V naught, it is equal to Km by V max into S plus 1 by V max. Okay, right. Yes. So this is going to be a plot between 1 by V naught and 1 by S. Okay. So this is a plot between 1 by V naught and 1 by S. Now there is going to be a y-intercept. Your y is equal to mx plus c, no? So there is going to be a y-intercept. So what is the y-intercept? It is your 1 by V max. Okay, y it is equal to mx plus c. So c it is going to be your 1 by V max. Okay, so what is going to be your x? X is 1 by s. What is m? M is going to be the slope. So what is the slope here? Km divided by V max. So Km divided by V max is going to be the slope. This fellow. I'll use some other color. Yeah, so this fellow. Wait a minute. This Km divided by V max. This fellow it is going to be the slope. So the equation is y it is equal to mx plus c. So c it is going to be 1 by V max. This is going to be the x axis 1 by x. And this is the slope that is going to be Km by V max. Till now any doubts you can just ask me. If it is clear, we will make up a move towards the next slide. Yes everybody, this is all clear to you. Shall we make up a move? Okay, fine. So there are variety of inhibitors. Okay, right. So the number one type, it is what is called as the competitive inhibition. Here for the same site, both your substrate and inhibitor both are fighting it. So this is, thank you Siji. So this is what is going to be called as your competitive inhibitor. So both are fighting for the same site, no? Yes Harry. So this is what is called as the competitive inhibitor. Okay. Whenever it is binding at the site that is other than the active site. Okay. Yes. So this is going to bind at the site that is going to be other than the active site. Then it is called as non-competitive inhibition. Okay. So this is going to be some other site, right? So in uncompetitive inhibition, okay, what it does, it is going to bind to the substrate, okay. So it is going to bind to the substrate, right? So when this fellow substrate is bound, then only this will come and bind. Got the point? Yes. Your competitive inhibition is like either enzyme or your substrate. Yes. In your non-competitive inhibition, when your inhibitor binds, the substrate cannot bind. In uncompetitive inhibition, it is going to be like when the substrate binds, then only the inhibitor will bind. Understood? If it is going to be the absence of the substrate, then your inhibitor cannot bind. Okay. Among these three, which can be your allosteric inhibitor? Among these three, which can be your allosteric inhibitor? Is it going to be a competitive or non-competitive or uncompetitive? Which is going to be your allosteric inhibitor? Yes? Which one can it be the allosteric inhibitor? Allosteric is going to be the non-competitive inhibitor because it binds to the site other than the active site. Okay, here it binds to the substrate. Okay, right. So it binds only if the substrate is bound. It binds to ESI. Okay, so this is going to be EI, right? So this is going to be like your EI only. Okay, right. But this is going to be like ESI. So that is the wrong one. Okay, so I mean it is not your allosteric. Allosteric is going to be your non-competitive inhibitor only. Understood? Yes, nice. Okay, great, fine. So now we are going to make up a move towards the next important one. Okay, right? So let us see what is that. It is going to be the inhibitor diagram. Okay, right. So this inhibitor diagram is very, very important for your examination. Yes. So almost majority of the examination, this question will be coming up. Okay, so let us see what is this. Okay, right. So now you are going to make up a graph between 1 by V, right, versus your 1 by S. Okay, so this is going to be your 1 by V versus your 1 by S. If there is going to be no inhibitor, this is how the line goes like. Okay, and if it is going to be with the inhibitor, it is going to form, yes Harry, thank you CG, it is going to form the CX. So CX is what is called as a competitive inhibition. Competition means always into, correct? Right, so this is going to be your CX. CX means it is forming a competitive inhibitor. Competitive inhibitor is always going to be your X. X means competition, no? Fight. Okay. So now let us see what is happening to your Km and Vmax. So under the competitive inhibition, the Km is increased. So what is happening to the Km? Yeah, Cx is the clue. Correct, Siji. So the competitive inhibitors, what happened to the Km? Km is increasing. But what happens to Vmax? It is a constant. Okay. So in your competitive inhibition, it is Cx. So now what happens to the Km? Km is increasing and Vmax is constant. Okay. So this is going to be for your competitive inhibition. So competitive inhibition, Km will increase, Vmax is a constant. So let us see what is happening with your uncompetitive inhibition. So usually I used to tell a clue, it is going to be U parallel, uncompetitive inhibition. U is parallel, right? So now what happens? Your Km is reduced and your Vmax is also reduced. Okay, so under the competitive, Km is increased, Vmax is constant. In uncompetitive, what happens? Km is reduced, Vmax is also reduced. So these two things one more time shall we see? Yes, everybody in the class, very, very important fellow. Okay, so we'll see it here one more time, right? Yes, so if it is going to be the competitive, the graph is going to be a X-shaped. And what is happening to the Km? Km is increasing. And what will happen to the Vmax? Vmax is the constant. Then, next it is going to be the uncompetitive. Yes, so second point that we saw now, it was the uncompetitive. So if you take this just a moment. Okay, if you take this uncompetitive, so how it is going to be? It is going to be parallel. If it is going to be parallel, what happens to the Km? Km is reduced. What happens to the Vmax? Vmax is also reduced. Got the logic? Yes. So Km is also reduced. Vmax is also reduced. That is what it happens with your uncompetitive inhibition. Very good. So now the third one that we are studying, it is going to be called as the non-competitive inhibition. So in non-competitive inhibition, like what will happen? Yes. So shall we all see in non-competitive inhibition what is going to happen with? Yes. In non-competitive inhibition, it is forming the shape of V. So I used to say it is the NV. Okay. Non-competitive inhibition. Okay, yes, absolutely. So in non-competitive inhibition, what happens? Km is constant, but Vmax is reduced. Okay, Km is constant, but Vmax is reduced. Okay, so one more time, shall we all write and see this? Yes, everybody in the class. Okay, first we saw about the competitive inhibition. So under the competitive inhibition, what will be the shape of the graph? It is going to be X-shaped. So what will happen to the Km? Km is increased. What will happen to the Vmax? Vmax is constant. Very good. Second, we saw about the uncompetitive inhibition. So under the uncompetitive inhibition, Km is going to reduce. What will happen to the Vmax? It will also reduce. Next it is going to be the non-competitive inhibition. So under the non-competitive inhibition, what will happen to the Km? Km is going to be the constant. Yes. What is happening to the Vmax? It is going to reduce. Can you see any similarity? Yes. Can you see any similarity? Yes. Here this is constant, there that is constant. Isn't it? Right. Yes. Absolutely. Sure. So this is how it is going to make it out. Yes, everybody. So this is understandable now. Okay, great. Fine, everyone. So that is how you can make it out. Okay. Right. Fine. Yes. Clear? Understood? No doubt now? Okay. Fine, guys. Yes, all. So I hope that now this is clear. Yes, these things are very, very important. Yeah, so many a times this will come, but the thing is we will not have the patience to remember. Isn't it? So shall I ask you true or false? So shall I ask you true or false? You will just let me know on this, then we will do the questions. Okay. Yes? Okay, fine. So I will go this side. Okay, fine. So in competitive inhibition, okay, right, Km increases, true or false? In competitive inhibition, Km increases, true or false? Yes, everybody. Come on. In competitive inhibition, Km increases. True or false? Very good. Yes, Km will increase. Fine. So the next question. Yes, Vmax reduces. True or false? Vmax reduces. True or false? In competitive inhibition, Vmax, it is not at all reducing. Vmax will be a constant. Okay. Yes, Km will increase. Vmax will be a constant. Okay. Right. So under the uncompetitive inhibition, Km reduces, Vmax reduces. True or false? So under the uncompetitive inhibition, Km reduces, Vmax also reduces. True or false? It is a true statement. Yes, absolutely, this is a true statement. Correct? So under the uncompetitive, your Km will also reduce, your Vmax will also reduce. Right. So the next one, it is about your non-competitive inhibition. Okay. So under non-competitive inhibition, Km is a constant. True or false? Km is a constant. True or false? It is a true statement. Yes, Km is a constant. So Vmax, it is increasing. True or false? Vmax is increasing. True or false? No. What will happen to the Vmax? Vmax should decrease. It is opposite to that. No. Your Vmax should decrease. Understood the logic now? Yes? So here the Vmax should decrease. Yes, absolutely. So yeah, it will reduce. Correct. So this is how you have to understand these questions. Now shall we take a few questions? Yes. Then our understanding on this aspect will be complete. For a reversible non-competitive inhibition. What is that? Non-competitive inhibition. Okay. So what will be the thing? It is going to be parallel or X or V or parallel. Which is going to be the correct answer? It should be a non-competitive inhibitor. Come on guys, everybody can make it out. Yes? Done or what? Yes? Come on everybody. Yes, N is V. Remember the clue. CX, U parallel, and then N it is going to be V. Right? So only this is going to be the correct answer. So this is going to be your competitive. No. So it is not going to come. Got it? Right. One of the graph is totally wrong. One of the graph is wrong. Which one? So for U parallel, which one should be at the top? For U parallel, which one should be at the top? Did you remember this? Yes? Did you remember this diagram? Who should be at the top? Your inhibitor only should be at the top. Correct. Did you see that? Yes. Only the inhibitor should be at the top. Only the inhibitor should be at the top. Okay. This is going to be the non-inhibitor at the bottom. Okay. So this graph, it is technically possible. This is not at all possible. Okay. So this is going to be the non-competitive inhibitor. Okay. This is going to be the uncompetitive inhibitor. This is going to be the competitive inhibitor, but this graph is not at all feasible. You cannot make one such graph. Got the point now? Yes, everybody? Okay. In competitive inhibition, what happens? Km increases, Vmax constant. Km decreases, Vmax constant. Km constant, Vmax increases. Km decreases, Vmax increases. Which is the correct answer for this question? Come on, everybody in the class. Everybody can make this question. Very, very direct question. We have also tried a lot with this question. Come on, guys. Yes. Done or what? Very good. It should be your Km increases, Vmax constant. Right. Fine. So this is what is going to be with the competitive inhibition. Okay. So in case of your uncompetitive inhibition, Km Vmax is also reduced. Km is also reduced. In case of your non-competitive inhibition, yes, Km is going to be the constant. Vmax is going to reduce. Okay, right? So this one, yeah, so this one you will never forget here on, I guess. Okay, good everybody, keep it up. For a new chemical entity to be a good enzyme inhibitor, it should have a higher dissociation constant, Ki, for enzyme inhibitor complex. It should have a lower dissociation constant for your enzyme inhibitor complex. Competitive type of inhibition, uncompetitive type of inhibition. So if an enzyme has to be a good inhibitor, I mean if a chemical, it must be a good inhibitor, what should be the property that it should have? Yes. What should be the nature or what should be the property that it should have? Come on. If at all you want it to be a good inhibitor, what should be the property? Yes, you can give your answers. Come on, everybody in the class. So how should be the property? It should have a low dissociation. See, if your E plus I, it is dissociating to form E plus I. I mean like if your EI, it is going to dissociate it to form E plus I, then it is no value, no. So it should have a lower dissociation constant. Yes, this EI, see, your E plus I, it is forming EI. This is called as K of association. This can disassociate to form your E plus I alone. So this should be low. Okay, so lower dissociation is only leading to your enzyme inhibition. Yes, or else it will go back to the original form, right? So that you don't like. Correct? Okay. Competitive inhibition of an enzyme, okay, by a competitive inhibitor can be overcome by. So how you will overcome the competitive inhibition? You are going to decrease the substrate, you are going to increase the substrate, you are going to decrease the temperature, increasing the temperature. Few options are like very dummy for you, right? Yes. Okay. Anyway, see here. Yes, G, very good. You are going to increase the enzyme concentration. So in competitive inhibition, it is fighting at the active site. So it is going to be like your enzyme, it is going to bind with your substrate, or the enzyme is going to bind with the inhibitor. Either or other choice. If this is more, this will win. If this is going to be more, this is going to win. Yes? Yes, Shraddha. Correct. Very good. B is going to be the correct. If you increase the substrate, inhibition is going to be overcome. But what will happen in case of your uncompetitive inhibition, in uncompetitive inhibition, if I increase my substrate concentration, what will happen to the inhibition? I am saying that it will decrease. True or false? In uncompetitive inhibition, if I increase the substrate concentration, the inhibition is going to decrease like that of my competitive inhibition. True or false? We know that in competitive inhibition, if I increase the substrate concentration, the inhibition is going to get reduced. Is the same happening with your uncompetitive inhibition? Not at all. Why? In uncompetitive inhibition, the inhibitor, it is going to bind your enzyme substrate complex. It is going to form your ESI. So definitely, if you keep on adding your substrate, it is going to form your inhibitor. Inhibitor is not going to reduce, but it is promoted. Correct? So this is only this overcoming is only applicable for the competitive inhibitor. Okay, it is not true for your uncompetitive inhibitor. Got it? Yes. In case of your non-competitive inhibitor, it is independent, no? So you don't worry about it. Okay. So coming to the next one, an allosteric inhibitor. Allosteric is going to be non-competitive. Okay. Allosteric inhibitor, it is affecting the active site of an enzyme by which of the following? It binds to the active site, preventing the substrate from binding there. It binds to the second site, resulting in the conformational change, which makes the active site less accommodating to the substrate. It modifies the substrate in a way that it cannot bind to the enzyme. It carries a chemical modification to the enzyme, which prevents the progress of further reaction. Yes, everybody, which can be correct? Yes, Siji? Good. Others? Come on, everybody in the class. Yeah, it is going to be the answer B. So, allosteric inhibitor is nothing but non-competitive inhibitor. So, it is going to bind the site other than the active site. Since because it is going to bind to the site other than the active site, it is going to make the changes. So, that is what is happening up here. Good. Which type of inhibition requires substrate to the enzyme before the inhibitor can bind? Just now we saw about this, right? They are asking which type of inhibition it is requiring the binding of one or more substrates to the enzyme before your inhibitor can bind. Yes? So it is requiring ES complex such that your inhibitor can bind. Which one is requiring that ES complex? Yes, everybody. It is none other than your uncompetitive inhibition, right? In case of your competitive inhibition, it is E plus I, okay, right? Yes, absolutely. In uncompetitive inhibition is equal to only ES plus I. This is going to be E, and your inhibitor is binding to the site allosteric. Okay, so it is not applicable. Correct. Only this is only going to be mandately it requires. Mixed is a mixture of these two. Okay, so that is different. But the correct answer is going to be your option A. It binds to ESI alone. So we can write it for competitive inhibition. You remember that diagram? Yes or no? How many of you remember the diagram we saw? I'll show you that one more time. Yes. So we just saw this diagram, no? this one, this one. Yes, if it is going to be your competitive inhibition, okay, yes, so if it is going to be your competitive inhibition, yes, either your substrate will bind, okay, either your substrate can bind or your inhibitor will bind. So this is only I bar, yes, this is only the competitive inhibitor. In case of non-competitive inhibitor, this inhibitor is binding to the site that is other site. Okay, so your substrate, this site is modified, your substrate cannot bind. But in case of your uncompetitive inhibitor only, yes, it is not binding directly, but where it is binding? It is binding to the enzyme substrate complex. This is the enzyme, this is the substrate. To that only this inhibitor is binding. Okay, right? Yes, now you got the point of why it is going to be your uncompetitive inhibitor. Everybody in the class? Oh my god. So it is clear like why this is going to be the correct answer? Yes? All right. Fine, everybody. Yes. Good. Fine. So the conventional, thank you, treatment for methanol toxicity is to administer the ethanol. Which of the following explains the best of this treatment? Ethanol acts as a competitive inhibitor to methanol. Ethanol acts as a non-competitive inhibitor to methanol. Ethanol destroys the enzymatic activity of alcohol dehydrogenase. Ethanol blocks the entry of methanol within the cells. Which could be the correct answer? Yes, everybody, which could be the correct answer? Yes, alcohol dehydrogenase enzyme can catalyze methanol, so it is going to form this formaldehyde. So the patient will become blind. Okay, right. So now you add something. Your ethanol, it is a competitive inhibitor. So this ethanol, it is going to bind. Okay, so its active site. Okay, it is an alcohol dehydrogenase. Okay, so this is a substrate. So now this acts as a competitive inhibitor. Okay, so instead of instead of methanol binding, this alcohol dehydrogenase will bind with your ethanol. So it acts as a competitive inhibitor. So the patient is going to be saved. Okay, so this formaldehyde is not going to be formed. So the patient is going to be saved. Okay, next question. Upon addition of reversible inhibitor, to this enzymatic reaction, okay, so the velocity profiles are generated, right? Fine. So now what is this red line indicating? What is this red line indicating? We studied, no? What is happening to your Vmax, Km? Yes, it is uncompetitive, non-competitive, competitive, or it is not at all inhibited. So what has happened here? What has happened to here Vmax? Vmax is changed. Vmax is a constant. What has happened to the Vmax? So this is your MM. You add inhibitor, this is the effector. So now this is going to be the question. What has happened to the thing? So any change in the Km? Any change in the Km? This is half Vmax. This is going to be the Vmax. Okay? This is the Vmax. This is going to be half the Vmax. Okay? Right. If this is it so? This is going to be the Vmax. Then this is the half Vmax. So Km, red line alone you see. You are not worried about the blue line. They are asking only about the red line. For the red line, is there any change in the Km? Yes? Think and tell me. I'll erase and show one more time. See? I am not talking about this blue line. Only this red line I am taking. Okay, so this is the red line. So for this red line, this is the Vmax. This is going to be the half Vmax. Okay, so let me take this as 0, 1, 2. So Km is going to be 1. So this is for your inhibitor. For your equation, what is the Km? It is also going to be 1. So Km is constant. Got it? Km is constant. Right. But what has happened to your Vmax? Vmax has reduced. So if Km is constant, Vmax from this point it has reduced to this point. What is the type of inhibitor? Got the logic? Same aspect that we studied today. So what is going to be the thing now? It is a non-competitive inhibitor. Yes. See here, if it is going to be a competitive inhibitor, very good. Km will increase. Vmax is constant. If it is going to be an uncompetitive inhibitor, Km, Vmax, both will reduce. In case of non-competitive inhibitor, Km is going to be constant. Vmax is going to reduce. Okay? So see this question. Your Km is constant like your mm. Ignore this blue line. This blue line is not at all in the story. Okay, it is ignored. Only red line. Vmax is reduced. Yes? Vmax is reduced. So Km is constant. Vmax is reduced. So it is going to be a non-competitive inhibitor. Understood this logic, everybody in this class? Yes, it is absolutely an important question. Okay, fine. So there are so many schemes and things coming up at Unacademy. So if at all you have not yet subscribed, yes CG, good. So please take time to make up a subscription. You can use my code Saranya Live if seriously you feel like the classes are interesting and worthwhile. Yes, so definitely there are a lot of things in the Unacademy Plus subscription. So under the Plus subscription you can continue on your learning in an in-depth manner and also in a continuous way. Yes, because these sessions are a little bit assorted, but under the Plus subscription it is going to be continuous, right? So you can come up with a subscription using my code Saranya Live. So all the very best for your preparation. I'll see you up at another interesting session. Take care till we meet, and also follow me at Unacademy. So at Unacademy you can find my profile as Saranya. Yes, kindly follow me and click on this notify me button such that whenever I post some classes, you will be able to get it. All the very best, guys. Catch you soon in another interesting session. Thanks a lot. Take